Hello, my name is Asaf Nakash. I'm a Senior Product Manager at Microsoft Defender for Cloud. And today, we're going to talk about how to protect your AI workloads from code to runtime with Microsoft Defender for Cloud. So when we are talking with customers, their main concerns are, first, they have data overshare and data leaks. Second, is emerging AI risks and threats, focusing directly on jailbreaking of AI models. And lastly, with open source model becoming more and more better, customers are being also worried about the model vulnerabilities. So in Defender for Cloud, we have a very sort of way of protecting AI application from code to runtime. And we always start by enabling secure development with app security and CI/CD security. This will help you to prevent vulnerability, misconfiguration, secret and code to secure the software supply chain. In the middle, we are continuously help you to reduce risk to your cloud environments with CSPM, Cloud Security Posture Management, and Cloud Identity Entitlement Management. This is helping us to detect those misconfigurations and helping you to resolve them at scale. Lastly, at runtime, with Cloud Workload Protection and Cloud Detection and Response, we're helping you remediate your threats faster, meaning we have a near real-time detection and response for compute and AI workloads, data and APIs in a unified XDR experience. Now, with the addition of AI to your cloud application, we're also helping you expand that synapse to an AI application too. We're doing that by detecting the AI platform in a multi-cloud way, Azure, AWS, and GCP Vertex AI. We're helping you detect the application that runs those AI applications, the AI platform like Kubernetes and containers, and eventually the data that's being used in AI to grounding reasons, and that will help us to help you protect your applications against AI-specific attacks like prompt injection, data poisoning, supply chain vulnerabilities, and wallet abuse. We're doing that by introducing two products to the marketplace. The first one, AI Security Posture Management, will allow you to start by gaining a complete visibility across your AI services, including Azure OpenAI, Azure AI Foundry, Azure Machine Learning, Amazon Bedrock, and new in public preview, GCP Vertex AI. Then we help you detect all of your models in use across all of those platforms to help you gain your complete visibility into the models that's being played in your organization. Next, because we know how to detect all of this misconfiguration, we can help you detect the attack paths that are being used to direct and indirect attacks of your AI application. Then we help you to remediate those risks faster, and this again in a multi-cloud manner. And lastly, we cram everything together to a single pane of glass in Defender for Cloud that allow you to focus on the urgent issues and get insight on your AI workloads. At RSA, we're also announcing GA to our Defender for AI Services, which is a threat detection platform helping you to continuously monitor for malicious activity, and that's powered by Microsoft Threat Intelligence to detect and respond to AI attack such as jailbreak, wallet abuse, and credential theft, and receive a complete context when enriching the alerts with a lot of context that we have in Microsoft Security to help you understand the IP address being used, what was the malicious prompt and evidence, and what was the sensitive information or credentials that are being accessed during an attack. And eventually, we help you correlate all of those attack sensors into one robust incident in XDR to giving you a complete understanding of what's going on and helping your SOC team to really respond quickly to emerging attacks. So how we are doing threat detection for AI attacks? We're doing that by looking at two main areas. The first one is the content that's being pushed into the AI model and response. We are scanning those prompts and responses to detect things that shouldn't be there, like jailbreak requests, like secret and sensitive data, like malicious URLs, and encoding and manipulation that the attacker is trying to do in order to manipulate your AI model. But sometimes that will not be enough. In order to really understand attacks, just looking at the content, it will not give you the complete picture. And this is why we're also looking at suspicious behaviors between a user behavior, we're looking at the application behavior, we're looking at the tool and the tool invocation that's being used in your AI application, and eventually we get a lot of more parameters by using the power of Microsoft Threat Intelligence database that have a lot of insights. So we are combining those insights and enriching the alert to giving you a complete view of what's wrong. And that's helping us really uncover the AI application. We will give you Defender for Cloud once we detect something wrong. We will give you a prompt and response evidence. We are capturing the prompt, capturing the response, and even if the prompt is being blocked by Prompt Shield, we're coming to the security product and collecting everything there. Prompt and response evidence, the application context, and the user context. This will help you answer questions like what was the user interaction with the model and which application were involved. Next, we're taking a deep look at the data being provided to the AI model. AI models are very, very powerful, but they are becoming more powerful when you connect them to your organizational data. So we can understand the RAG that's being used and detect the storage used for grounding in order to provide a response. This is helping you answer a question, what was the information provided by the model in that attack? And lastly, and that's something that is special, we're taking all of that data from runtime and we're putting it all the way back to posture to give us a complete context of what the application is doing. This will help us to answer the question, okay, I understand from attack that a specific thing is being used in my application. How can I use that in posture to better prioritize where I need to focus first? And what we will show is prompt to grounding mapping. When we're looking at the prompt, we understand the grounding, we detect the storage that's being provided the grounding data to, and can detect that storage as used for AI grounding. So let's see how everything comes together in a demo. In this demo, I would start with an application I created, and I would try to jailbreak it using then, do anything now, prompt that convince the application to stop what it's doing and start listening to what I'm asking it for. We will see how it's being interfered with Prompt Shield and being blocked. Then we will go to XDR and see the alert that we generated and see all of the richness of the data we added to that alert to give the SOC analyst a complete context of what's wrong and how we can close it down. And then we see how with the understanding of use for AI grounding source, it can help you on my posture day-to-day task of pre-breach to really understand where I need to focus first to reduce the risk to my AI workloads. So as I started, as you can see, I put the do anything now prompt, and I've been blocked by Prompt Shield. Now, when I move to XDR, this is the alert and the incident that's being generated. You can see a jailbreak attempt on your AI model deployment was blocked by Prompt Shield. I'm getting in, I see the entire application, and when I connect to the related activities, I can really see everything that we collected during that attack. Started with this prompt suspicious segment. This is the prompt that was suspicious. Continued with the user details. This was the user IP. This is the authentication method. The user used Entra ID to authenticate. This is the user ID in Entra. This is the user agent it was using. And also the application. This is the application that's being used. This is the confidence of the jailbreak attack. And also this is the grounding method being used with the data behind the scenes. Going back to MDC, we can see in the data and AI security dashboard that I can focus on critical and high severity recommendations. This is automatically being sorted out, but the most important one to the least important one. And that grounding data context that we added, helping us to fix those problems first. I can look at specifically alerts that are associated with the risk factor of grounding data, and I can see what I need to resolve in order to reduce the risk of data exfiltration through my AI application. Next, looking at attack path that we generated, we click on the critical and high severity attack path, and here I can see an attack that starts with a container that have vulnerability and open to the internet, and that container allows lateral movement to a storage used for grounding. This will allow attacker to change the data in the storage, meaning change the way the application is working. And this is the attack called data poisoning. You can see that I have the complete graph of the attack. starting with a high severity vulnerability, getting all the way into the storage account, and going to Insight, I can see that we detected this storage as used for AI grounding by indicated with prompt source of prompt analysis. In Runtime, we analyze the prompt and we understand this is the grounding. This is the hidden link between the application and the grounding data. Next, going over to AI closer look, we can see the AI discovery. This is all of the AI resource and AI-related resource that are part of your AI workloads. Starting with containers, these are the containers used for AI. And here we can see, for example, a container that we detected is used for AI because it's running MCP, Model Context Protocol. So this is a junction in your AI application that can go to very interesting areas in your environment. So we can detect that and help you make sure it's well protected. And for example, this storage is have the OpenAI libraries, meaning is used in OpenAI. Next, customers want to really understand all of the models they have in their environment across multi-cloud everywhere around. You can see that we have 15 models deployed in our environment. Going over them, for example, we can see a DeepSeek R1 model. They're being deployed, and I can see the deployment. It's being deployed in Azure OpenAI. It's a model as a service. I can see the Azure OpenAI environment too, Azure AI Foundry environment. Next, I can see the threat detection with all of the richness of the alerts that we have. I can see prompt injection. I can see ASCII smuggling alerts, and many more alerts that we are continuing to have available at GA. And lastly, for those like data poisoning attacks, I can see resources that are used for grounding and are open to the internet, meaning the attacker can attack them, change the way your application is doing grounding to data, and change the way the application is working. You can see that they have storage open to the internet and used for grounding. Okay, so I want to thank you for joining me today to see our releases in AI security, and I hope to see you all soon. Have a great one.